Hi everybody, this is Brad Dyke. I'm reaching out to you in the test environment lab, which I've got here in the background. And I'm back. Unfortunately, some things really significantly happened. Um, and I lost my mom. And so I had to take a little bit of time away from things, away from helping people, take care of my own resources and needs, and get us in a better place family wise. And so because of that, I had to step away for a bit from doing recordings and doing R&D work and so on. But I hadn't forgotten you guys, and I hadn't forgotten the things out there. So getting some really good requests on how do you transition from engineering and execution, working on environments back here like you see, and moving into the era of software catching up with hardware. So that's what we're talking about tonight. It does relate to DevOps to a degree, because it's actually the principal protocol that's driving the nature of continuous integration to continuous development. Because the threshold of hardware in the industry of IT technologies is that the nature of the technology has always been kind of one-sided for many decades. I'd say at least 30 years. And that is, there was a leap and bound from the era of mainframe technology to reinvent itself. This is the era of the x86. And the x86 platform, such as you can see over here, these platform environments, hardware-wise, RAM resource-wise, and so on, technically really did far exceed even the operating system's capacities. We know that because over time, as operating systems would evolve from Windows NT and so on, we find that always the operating systems is definitely behind that level of technology that was deployed. That is not the case so much now. What is the case now is that we're starting to see that the x86 based technologies, the ARC technologies, the RISC technologies have plateaued. They've hit a level of functionality. Bandwidths are becoming defined. There is no more ultra this and features ultra and so on. We're really truly beginning to hit more of a plateau. There are more technologies over the hill that are coming that will raise that bar yet again, but they're not ready. And it'll take another 5 to 10 years for that technology to reinvent, just like the x86 reinvented the mainframe environments and so on. So that's what we're talking about here. The nature of this particular beast that we're talking about right now is finally software catching up with today's modern hardware. And I can pretty much say yes. The reason why I'm saying that is because we're finding that we can now parse hardware into sub-environments. No, not virtual machines. I'm not talking about that. And I'm not talking about VMOSs or compartmentalizational, sectional kind of stuff. What I'm talking about is genuine segmentation of what we call our pool of resources, our CPU, down to your compute level, to your storage, to your RAM, and so on. And we're reinventing them in different colors and flavors using what we call quality of service to offer high-end, medium-end, low-end, but it's all sitting on this board. Nothing like that existed 15 years ago. So what I mean by that in a nutshell is really the advanced nature of today's motherboard technologies and their bus bandwidth pathways allow you to create what we call a sub-entity, actually sub-entities, just depending on how many cores you have available versus your thread counts versus your RAM resources and of course your capacity that's out there. With this technology specifically is important because the technology is based on the individual board platform. In the old days, we would have to take many, many, many machines to create that environment. We don't have to do that now. A single environment, such as one of these Dell 700 series single nodes, have the exact same power as this motherboard, that has the exact same power as a server motherboard. The only limitation is if there are added busways, higher computational capacities by higher compute processors, many more banks of memory opposed to the traditional 4. But the cool thing about this, and this is why I do the videos I do, is you finally have it from the basic smallest footprint to the largest chassis motherboards out there, all able to do the same thing. This means we have come to a plateau. We have come to a standard of functionality. Now, with that includes the software. So now we can talk about the software side of things. In CI/CD, or continuous integration and deployment environments for continuous perpetual upgrade processes, we've learned that with more code-dependent processing, we have the ability to be able to go into more of the hardware level resources, which means that we don't have to load a basic operating system anymore. In some cases, we don't need an operating system. We can just use containerization and work with a platform like Docker, or Commigine is another resource out there that can do that. But they're not the only ones. Some feel more comfortable with understanding that there are limitations to serverless platforms, that they kind of still like the ability of being able to do virtual engines and virtual platforms more effectively, and it seems to be still the common standard today. With software evolving and catching up to the hardware, eventually we will hit what we call the plateau of both service and infrastructure. Service is on the software side, and it's maximizing its resources on the infrastructure side, which is network, compute, RAM, storage. It's important to remember one thing: you don't need to have a relationship of those below. So the whole nature about plateauing is the capacity of the playing field for software and hardware, with integration and deployment, with better streamlining in your operations environment that use technologies like CI/CD or DevOps for those executions. Remember, DevOps is just a part of the greater scheme of operations, because you still have account management, control, access, infrastructure, logging, backups, and all the other things that have to be done. But the key thing about being able to take the maximum effect of your hardware for what's available to you, with the maximum outreach of the coding of the software you're trying to bring to the table, means that your PHP, your Apache, your print configs, your build out configurations, your Docker resourcing, and so on and so on and so on, will be actually very, very, very tight to those environments, and at a point where everything will start to plateau. Now, what does that mean in the industry? Well, in a nutshell, it means that AWS, Google, and so on will also plateau. They will plateau based on the nature of, well, if you want to use the terminology of things such as Moore's Law and so on, that they are cresting on the plateau. With that, then they'll have to pursue other strategies like better software tools added to your environment, better redundancy structures for your pairing, going HA modes only, no longer offering single node deployments, and just doing a lot of tweaking, but it's still the same equivalency. You're not truly getting any improvement. You're just getting better management or better offers for the same dollar, because that's the battle. It's the price point you pay for the resources that you're going to continue to maximize. Today, AWS and Google and so on know this already. If you look at how they structure their infrastructures, to support DevOps and, cloud environments or multi-hybrid environments, or tiered hybrid environments or regional hybrid environments, and so on and so on, is to try to muddy this water a little bit more for a little longer until they can see about getting some additional quote unquote buzz technologies into the equation to make their stuff more valuable once again. Because as the value comes up and we plateau and we get streamlined and we learn how we're doing things, then we start dropping the cost down and the discounts come back and help you continue to drive that cost down. With getting software and hardware equal, it means one of the very important things. In these environments, a CPU, a central processing unit, is hard-coded to be a central processing controller, mostly. It handles control sets and executes workloads based on its pipes, pathways, resources, and end results. Unlike the classification processors used in video cards, which are basically empty processors that are loaded with software code, and then they're given instruction, and then both the answer, which is documented and taken off of the platform itself, and of course the code that was instructed to do the work is either partially or completely wiped clean and reinitiates the process. I'm not done yet. With that, there's also other new forms of compute processing that exist. Yes, storage. I kid you not. Now, what we're talking about is the merging of cryptology style technologies with programmable CPU processing with other processing load environments. What's the cardinal secret about digital technology? I've been preaching this from the very beginning. The fact is, everything, I don't care what it is, if it's a hard drive that spins, an SSD drive, a network card, a motherboard, an NTU, a GCL, a GPU, right? They all basically have the same structure. They have a processor, they have resources to support the processor, and they have a set of execution software codes that allow the deployments for these systems to be added to the environment. So what are the new generation technicians doing here in this environment? Okay, we got hardware which is kind of sticking here. It's only getting better. We can add more cores, we can add more RAM, we can add more storage, but the performance of each of them pretty much reaching their limits, or it's fairly close to the end. Over here we have these seriously massive increases in performance capacities in software that are equalizing and starting to get the full maximum response back from the hardware, which is unprecedented, by the way. That's why back in the day I said a 1070 GeForce card is still a great card, because most of the games and video systems environments out there haven't taken full effect of all the features of these cards. And the only reason why GeForce is staying in business is because they keep throwing CPU power into that equation and just keep piling on resources to make it look better. But the software coders haven't taken the time yet, they're doing it, to get it fully maximized. And now I can see the justification for from a 1070 to a 270 or a 370. But I wouldn't go any farther than a 370. They still have a ways to go. The key detail here is that every environment, even a digital watch, they all have the same basic constructs. And the software is getting so good that these guys who want to turn anything into cryptocurrencies are reaching out to use them. We have MPUs creating crypto NTU, that's network translation networks, by using your network processors on the actual NIC cards. And they've got hard drives out there that are stacking up hard drives and using them to calculate answers, and so on and so on. So what's happening is the younger generations are really pushing the envelope on the standard that the industry standards put out there. And this has been a race that's been going on from the very beginning. Software has lost this battle for probably 25, 30 years. Only in this past 5, 6, 7 years have I finally started to see those environments starting to become equals. Not in all fields yet, but it is coming. That means that basically any component on a motherboard technology footprint such as, this typical Asus Z390 motherboard, is that I have a resource pool here, my CPU. I've got my RAM CPU, which is up here. I've got my PCIe's here, which will give me additional open resources. It doesn't matter if it's a 1 or if it's a 16 or a 32. The point is, they all offer whole new compute environments out there. The only thing I haven't seen yet, and I don't know if this is going to work, is somebody turning a digital power supply into some type of compute process. Power supplies are power supplies. Not true. There are some nice ones out there that are all digital and they're very small. And then you've got the more traditional solid state type that don't have that kind of functionality and would never be able to do compute processing, not effectively. So with that being said, you have eye-opening experience in the industry. Young kids coming in as coders, developers, and so on, looking at things more holistically and saying, hey, you guys in the standards up there, the guys who established the standards like RAID and parallel processing and asymmetrical mode processing and so on, and USB and so on, and SAS and SATA and so on, we see your stuff in a different way. We're going to do it without you, and we're going to come back and show you what ZFS looks like, which, by the way, is a catchphrase because ZFS was around as a hardware environment from Oracle when they bought Sun Microsystems a long time ago. But the only thing that survived that transition was the operating system. All the hardware faded away because it just was way too ahead of itself. ZFS, the software OS environment for storage, was spot on, and that's what developed into what we see today. Now, this also predicates to the operating system environments as well. I think that as we're going through this process and this next round of generations of administrators and developers are going to truly redefine the nature of the value of an operating system. And it will probably be the equivalency of an eye-opening event for Novell, for as Novell was basically completely displaced by Microsoft, and so on and so on. This will be done in the open source industry environments, and some of us have already transitioned to that kind of environment using Linux environments and getting away from the more standardized operating environment deployments. But it's also happening in the VM industries as well. You've got Proxmox out there, you've got other freebies out there that have all the open source functionality of that of an operational production environment. Only thing they're missing is a warranty coverage and support. And you can buy those separately if you need to. But the overall goal here is to say, hey guys, now this era of compute and resourcing for the industries relating to getting my operations, my DevOps, my software, and my hardware environments all together into a homogeneous environment is finally here. We don't have any major true code updates that are going to change that anytime soon, such as PCIe and so on, because again, on that side of the fence, most of those technologies are very close to the end of their maximum capacities that have been documented and released to the public. There could be special little surprises here and there, but they're pretty rare opportunities. Well, I just wanted to give you guys a quick 1, 2, 3 blurb on this, because as I've been doing, being a director of the company I work for, and I'm mentoring the DevOps environment and getting my resources lined up based on the lesson 1, which is always know how it's being done today first, before you can improve upon it in the future. 2, document, document, document. Once you've accomplished that, it doesn't matter who does the work, everybody can do the work. No single points of failure. Thirdly, playbook strategies using run books to keep things organized, structured, execute. It's a simple process. Don't make it complicated. Just don't do it. It doesn't need to be. This will become your mechanism. That's how you create the DevOps mechanism. By learning how it's done today, you build the integrations for how that works, then you can begin to transition. There is your DevOps mechanism for going forward. Because every single company out there is unique. That's why DevOps is not so easy to get off the ground. using a common standard. It doesn't fit. You know what I mean? So you take a step back. Say, well, how are you doing it today? Here we go. Now the lesson's making sense now. I have these kind of resources. These are my compute resources. Okay, what are they? Is your code optimized for that? DevOps. Get in there, streamline those configurations, optimize those functionalities, but the way they do it today. Master that. Become the owner of that. Then and only then will you now know the mechanism that's going to allow you to transition to an automated process down the road. You just can't go automated like that. You just can't. Normal window of projection is 24 to 36 months to accomplish that. And that's pretty accurate. Even if you're a smaller size company, but have a resource of, I would say, 50, 60 people, it's going to take time because you got to move what you do things today into what you need to make them look like tomorrow. Don't be afraid of that and don't be defeated. Just line them up task by task and start ticking them off one after another, and keep your teams well informed on the aspects they need to be informed on. They don't need to know everything. They just need to know what they need to know to be successful. Don't forget that. So I'm going to let you guys go. You take care. I'm back to doing videos again, so that's another little side note. If you guys have any questions, please leave them down in the notation. I'm going to be doing 2 more software presentations or management presentations, and then 1 hardware specification video as well. I'll get those out there, so I have like 4 or 5 to play with over the next month or 2, and we'll see what the feedback looks like from that. All right, God bless, take care, and have a good evening.